Now, let's see general information of wind power. Actually, wind power technology has been developed since 500 Anno Domini or 500 years after Christ born by Persian using windmills. Next, in 1800s era, the wind technology upgraded into holiday windmill. In 1900s era, world first offshore wind farms begins operate. Then in 2000s era, there were already 15 million US homes powered by wind energy. Did you know why wind energy is classified as a renewable energy? It is because the electricity that is generated from wind energy is a renewable source, because as long as there is sun, there will also be wind. For your information, the largest wind farm in the world is Gansu Wind Farm project, which is located in China. The project generated 20 gigawatt power, consists of 7,000 wind turbines. The average wind speed in that area is 7.9 meters per second. The optimum annual average wind speed for wind turbines to operate or generate electricity is 4 meters per second for small wind turbine and 5.8 meters per second for utility scale turbine. In fact, annual average wind speed in Malaysia is only 2 meters per second, which is not achieve the optimum speed for wind turbine to generate electricity.
Firstly, I will explain about the definition of wind power. What is wind power? Wind power is the process by which the wind is used to generate mechanical power of electricity by using a wind turbine. Wind turbine will convert the kinetic energy in the wind into mechanical power. Okay, we move to the classification of wind power. Wind power can be classified in various ways based on location, scale, turbine design, capacity, and connection. Understanding this classification helps us better appreciate the diversity and versatility of wind power as a renewable energy. The first classification is based on the location of the wind turbines. We have onshore wind power and offshore wind power. Onshore wind power refers to wind turbines installed on land, typically in open areas or hills and mountains. Offshore wind power, on the other hand, refers to wind turbines installed in bodies of water, usually in coastal areas or in large bodies of water such as lakes or seas. Offshore wind farms are often built further out to sea to capture stronger and more consistent winds. Offshore wind farms are often built further out to sea to capture stronger and more consistent winds. The next classification is based on the scale of wind power installations. We have utility scale wind power and distributed wind power. Utility scale wind power typically refers to large wind farms that generate a significant amount of electricity and are connected to the power grid. These wind farms can consist of hundreds of wind turbines and are usually located in areas with high wind potential. On the other hand, distributed wind power refers to smaller wind turbines installed closer to the point of electricity consumption, such as residential, commercial, or industrial buildings. These decentralized systems can provide power directly to the location where it's needed, reducing transmission losses. Let's now look at the classification based on the design and orientation of wind turbines. We have horizontal axis wind turbines, which is HAWT, and vertical axis wind turbines, which is VAWT. Horizontal axis wind turbine have a rotor shaft that is parallel to the ground, and the blades rotate around a horizontal axis. These are the most common type of wind turbines used for large-scale wind power generation. Vertical axis wind turbines, on the other hand, have a rotor shaft that is vertical, and the blades rotate around a vertical axis, while less common, VAWTs can be suitable for certain applications such as urban and rooftop installations. Another classification is based on the capacity or output of wind turbines. We have small-scale wind power and large-scale wind power. Small-scale wind power typically refers to systems with lower capacity, often used for residential or small-scale commercial applications. These systems can provide power to individual homes or businesses. On the other hand, large-scale wind power refers to systems with higher capacity, typically used for utility-scale power generation. Large wind farms with multiple turbines can generate significant amounts of electricity to meet the needs of entire communities of regions. And the last classification is based on the connection of wind power systems. We have grid-connected wind power and stand-alone wind power. Grid-connected wind power systems are connected to the power grid, allowing for the injection of electricity into the grid and drawing power from the grid when needed. This enables a reliable and continuous supply of electricity. Stand-alone wind power systems, also known as off-grid systems, are not connected to the grid and are designed to operate independently. They are often used in remote areas or in places without access to the grid.
Now, let's move to working principle of wind turbines. So, how do wind turbines work? In basic terms, wind energy drives the rotation of a windmill's or a tower structure's blade, which is in turn drive the shaft of a turbine located inside the building. Then, when its shaft moves, this turbine acts as a generator, generating power. Then, this electricity is provided to a residential, a community of consumers, or it is gathered with other wind turbines, or we call wind farms, to supply a huge transmission grid. Now, let's proceed to the characterizations, properties, and design of wind power. First, most wind energy comes from turbines that can be as tall as a 20-story building and have three 200-foot or 60-meter long blades. Second, because wind can be more powerful and less volatile higher in the atmosphere, placing turbines on towers 100 feet or 30 meters long, about the height of the Statue of the Liberty, can help them generate more electricity. Third, a modern wind turbine produces electricity 70 to 85% of the time, generating different outputs at different times depending on wind speed. Next, there are three main parts of the wind turbine in motion, which are rotor, multiplier, and generator. First, rotor. The rotor composed of three blades and the bushing that joins them together. Its function is to capture the force of the wind and convert it into mechanical rotational energy. Second is multiplier. The multiplier connected to the engine by means of a shaft. Its function is to increase the rotational speed from 30 revolutions per minute or RPM to 1500 RPM. Third is generator. This element is responsible for converting the mechanical energy of rotation into electrical energy. Other than that, wind turbine towers are generally made of steel. The blades are made of glass fiber, reinforced polyester, or wood epoxy. The finish in most models is made to reduce reflected light.
Let's move to the next slide. Here we have 5 positive environmental effects of wind power. One of the most significant benefits of wind power is its contribution to reducing greenhouse gas emissions. Unlike traditional power generation methods, wind turbines generate electricity without emitting carbon dioxide or other harmful greenhouse gases. By harnessing the kinetic energy of the wind, it helps to reduce reliance on fossil fuel-based power generation, which contributes to climate change. Another positive effect is the reduction of air pollution. Conventional power plants, especially those relying on the fossil fuels, release pollutants such as sulfur dioxide, nitrogen oxides, and particulate matter into the atmosphere, contributing to poor air quality and adverse health effects. Wind power, on the other hand, produces no such emissions, resulting in cleaner air and healthier communities. Next, water conservation. Where water conservation is a pressing concern worldwide. Many traditional power plants consume substantial amounts of water for cooling purposes. In contrast, wind power does not require significant water usage, thus alleviating the strain on this vital resource. By embracing wind energy, we can promote responsible water management and ensure its availability for future generations. Next, land use efficiency is another good effect of wind power. Wind turbines occupy relatively small land areas, and the land surrounding them can still be used for various purposes such as agriculture or grazing. The dual use of land for wind power and other activities can provide additional economic benefits. Lastly, wind energy is derived from an abundant and renewable resource, which is the wind itself. Unlike finite fossil fuel reserves, the wind is an inexhaustible source of energy. By embracing wind power, we diversify our energy mix, reduce our dependence on fossil fuels, and create a more sustainable future. Next part, we will be discussing another important topic, the negative effect of wind power. While wind power is often praised for its environmental benefits, it's crucial to recognize that it also has some downsides that need careful consideration. Firstly, visual impact and aesthetics. One of the primary concerns raised by critics of wind power is its visual impact. Some people find wind turbines visually unappealing, particularly in scenic of natural areas. The presence of wind turbine can significantly alter the aesthetics of the landscapes, leading to debates and conflict within communities. Another negative effect is the noise generated by wind turbines. Although modern designs have reduced noise levels, concern still exists, especially for residents living close proximity to wind farms. Additionally, wind turbines can pose risks to birds and bats. Their rotating blades can collide with flying wildlife, particularly in areas along migration routes or habitats with high wildlife activity. Habitat disruption also one of the negative effects. The installation of wind farms may require clearing land or disrupting habitats. This can lead to the loss of vegetation, soil disturbance, and potential impacts on local wildlife population. Proper planning and environmental assessment are crucial to minimize the disruption of ecosystems and biodiversity. Lastly, electromagnetic interference. Wind power requires transmission lines to connect the turbines to the electrical grid. These transmission lines generate electromagnetic fields which can potentially interfere with certain electronic device or communication system. Adequate management and precaution are necessary to minimize electromagnetic interference and ensure uninterrupted functioning of nearby technologies. In conclusion, wind power offers significant advantages and challenges. It also diversifies our energy mix, promotes sustainability, and reduces our dependence on finite fossil fuels. It also have the potential to create a sustainable energy landscape that benefits both present and future generations. That's all from us. Thank you.